Hello everyone, welcome to Gyan Deep, a channel where we talk about everything that relates to data science. Quick recap of the previous session. We started by understanding one of the Kaggle's competition, right? Which is Feedback Prize, the English language learning competition. We started by doing some very basic stuff involved in building the deep learning model. So we essentially imported the libraries, then we loaded the data, we defined the config, we also created the dataset class, and then we created the model architecture. Now, in this lecture, we want to have the understanding of the trainer class. It's one of the most important aspects of a deep learning model, and to build a very robust, efficient, optimal deep learning model, it's important to understand it well. So in this session, I'm going to brief about the theoretical aspects of the trainer, which means I will touch upon some of these stuff like the scheduler, the optimizer, learning rates, and so on, backward propagation, and so on. And then over the next couple of videos, I'm going to cover the training of the model, its evaluation, and then the inference. Okay, so let's understand the trainer a little better. It is typically a class which takes the data, model, and config as the input and trains the model efficiently. There are several steps involved into it. It first starts by setting the model to the train mode, right? We get the inputs and the targets and we send them to the CUDA or GPU, right? The forward propagation is then done where we get the model outputs. With the model outputs there, then we also are able to calculate the loss. And then we do the back propagation of the loss where we essentially calculate the gradient and update the weights of the parameters. We then optimize the weights and then schedule the learning rate. We perform the above steps for all the rows, right, or all the items in the dataset class, and then we set the model to the eval mode. We then perform the steps 3 and 4, which are the forward propagation step, getting the model output, getting the loss, and so. And then finally, we perform above steps for all the epochs that might be there in your config. So that's what the trainer actually does, right? All these different steps. And before we get into the coding, some of these things like backward propagation, optimizer, scheduler, it's very important for us to understand them. So let's learn a little bit more about them. Okay, the first thing is actually the loss function. Okay, so in this function, it is stated to be MCR MSE, which is mean column root mean squared error. So what is that? MCR MSE, if you see the mathematical expression, it looks like this. We try to understand it better. The term in the bracket is Yij minus Y hat Ij squared, and then we take a summation of it for all the items in the data set for that particular column. We then take a mean of it and then the square root of the square root of it. So this essentially gives us the root mean squared error. So that's the expression for our MSE. We calculate this component for all the columns or all the classes for which we need to get the get the predictions, right? And that's why we have the summation of j is equal to 1 to nt, and we take a mean of it 1 by nt there, and that's what gives us the MCRMSC. Next, the backward propagation. In the backward propagation step, we essentially do the loss dot backward, which computes the differential of the loss that we calculated above. And so essentially this gives us the d by dx of the loss for every parameter x. These are accumulated into x dot grad for every parameter x, right? Now, the next important term is optimizer. The optimizer dot step updates the value of x using gradient x dot grad that we calculated in the previous step, the gradients. And hence, say for example, if we have SGD optimizer, stochastic gradient descent optimizer, then it would perform x plus is equal to minus LR into x dot grad, right? So it's updating the weight of x. This is the value that we got, the updated value that we got, the gradients that we got here, x dot grad, and also the updated value of the LR, which we will understand in the next slide. Now, there are two other important terms or important methods actually to note. The first one is the optimizer dot zero grad. Now, this clears the x dot grad for every parameter x in the optimizer. It's important to recall. It's important to call this because we do not want any accumulated gradient when we are calling the loss dot backward. Otherwise, the gradients would actually add up and it will give us the very different result than what we would have expected. Next is torch dot no grad, and this disables any gradient calculation. What it means is no further gradients are calculated in these specific steps, right? And we essentially want to do that when we are doing the performing the inference or evaluation, because there is no loss dot backward involved, and hence we do not want any gradient to be calculated, and hence we want to and to in order to have the memory optimization done, given that your requires underscore grad will already be there when you are updating your optimizer, right? In this optimizer dot step during the training part of it, right? Hence, it's important to have the torch dot no grad. Now there are multiple different types of the optimizers which are available, and right now I think Adam and Adam W, they are the ones which are very much in the use. In fact, they are the most widely used ones. The Adam is essentially the adaptive optimizer, and what it means is it automatically decides on the number of steps it should be taking to get to the most efficient loss. Think of it in this way that we are trying to reach to the bottom of a valley and seeking the help of an optimizer. In that case, the optimizer would look into the changes in the gradient and would allow us to take the larger steps downward if it anticipates or if it finds that there are minimum changes in the gradient. But then if it sees that there are too large a change or too often a change in the gradients, then in that case it slows down and lets us take the smaller step. That's how Adam essentially works. Adam W is an enhancement over Adam, and it's stated to generalize much better than Adam. Okay, so then we have another important term called scheduler. It is used to adjust the learning rate. In fact, torch.optim.lr scheduler provides several methods to adjust the learning rate based on the number of the epochs. It takes optimizer as the input and hence is applied after the optimizer's update. There are several schedulers which are available on the torch, right? And the important ones is what I have listed here: reduce LR on plateau, then cosine annealing, warm restarts, and step LR. Reduce LR on plateau. This essentially reduces the LR until the specified matrix actually doesn't change. So if there are not much changes in the specified matrix, then this scheduler would automatically make the changes in the LR. Similarly, cosine annealing form restarts. What it does is it starts with a large LR and then aggressively brings the LR down to the smaller number, very much close to zero, right? And a smaller value, very much close to zero, and then again raises it to a higher value. And so, as such, it follows a triangular kind of a pattern, right? And it's believed to be very effective when it comes to generalizing a deep learning model. In case of step LR, essentially the learning weights are changed or adjusted after every box. In the next video, we'll go through the code explanation of the trainer. Thanks. Thanks for watching the video.